Alright, so here we are with lecture 1.8. We're looking at inequalities. Okay, so one of the main properties for inequalities that differs from a regular equation is that your inequality sign will flip when you multiply or divide by a negative. Okay, for example, so if you had an inequality sign like this and you multiplied or divided by a negative, your sign would have to flip. Okay, now remember, that is just when we're multiplying or dividing. Okay, not when we're adding or subtracting. Okay, so good to keep in mind. So let's take a look at some of the examples. Solving linear inequalities. Okay, so focusing just on the linear ones, which means we just have x to the 1 power. Let's see. Solve the inequality, graph the solution, and write your solution in interval notation. Okay, so solving inequalities, linear inequalities at least, are very similar to a regular equation. Okay, so if you think of this as just being an equal sign, what would you normally do to solve for x? Well, we would divide by -3. So let's go ahead and do that to both sides. But what just happened here? I have just divided by a negative number. And what did I say about a property of inequalities? You need to flip it when you multiply or divide by a negative. So on this exact step, and please make sure you do this on your work, once you divide or multiply by a negative, you need to flip the sign on that step. Okay? So we've done that, that cancels, and then we have x is now greater than 54 divided by -3. Okay? And that's going to be 18, -18. So x is greater than -18. Let's go ahead and draw our graph. Plotting down my 0, my -18. I just use 0 to indicate that I know where the negative would be. Alright, let's see. So I have an open circle because it's just greater than. We don't have the equal to symbol. And then my x values are greater than -18, which means they're going to be bigger than. Okay, so there's my graph. And finally, my solution in interval notation. Okay, so remember, interval notation, it's like reading from left to right. What's the first number I start with? Is -18. We're not including it, so we're going to use a parenthesis. And then we go on and on and on till, well, we don't actually stop. We go on till infinity. So we're going to go ahead and use infinity symbol. And remember, infinity always uses the parenthesis. You can never actually touch the end of infinity. So there we go. Our graph and our solution in interval notation. Okay, let's take a look at B. Now B is different, like a compound inequality. Notice there are two inequality symbols. This one's kind of interesting. Sort of a similar rule applies for equations. You know how what you do to one side, you do to the other? In this case, it's what you do to one side, you do to all three. So we want to get x by itself, and at the moment, x is in the middle, and there's that -5 and that 2 being times to the x. So first, let's get rid of the adding or subtracting, which means we're going to get rid of the 5. So we add 5, and that cancels. And what we do, add 5 to the other sides. Add 5, add 5. That's going to be 8 is less than 2x, which is less than or equal to 14. Okay. Ooh, x is almost by itself. Let's go ahead and divide both sides by 2. Or all sides, excuse me. Do I need to flip the sign? No. Okay, I have divided by a positive number, which means I do not need to flip the sign. Okay, so we're all good. 8 divided by 2 is 4, so less than x, which is less than or equal to 14 divided by 7. Sorry, 14 divided by 2 is 7. Jumped ahead of myself there. And now we have our x value alone by itself in the middle, and we can go ahead and graph. Okay, and my points 4 and 7. Let's see. So I have my bubbles on my points. Do I include 4? No, I don't include 4. We don't have the equal sign. Do I include 7? Ah, yes, I do include 7 because we have the equal to sign. So let's bubble in the 7 value right there. And then our x value is in between these two. So we'll go ahead and draw a line in between the two. And there's my graph. Lastly, let's draw our interval notation. So reading from left to right, we start at 4, but we do not include 4. So we use the open parenthesis. And we continue until 7, and we include 7. So we use our bracket. And that's our interval notation. All right, moving on to non-linear equalities. So a teensy bit more complicated. And here's the steps for it. So first, you need to set your inequality to 0 and then factor it. Okay, so if I take a look at A, notice this is not equal to 0. There's a -2 there. So we'd need to fix that first. And then we are going to identify our critical values and use test points. So let's first do the first step. Set it equal to 0. All right, adding 2 to both sides to set this equal to 0. So I have x squared plus 3x plus 2 is greater than 0. And factoring, x plus 2, x plus 1 is greater than 0. All right, so next step is to identify the critical values. And please go ahead and the notation that I show on this page, please go ahead and show this on your homework. I will be looking for it. So my critical values, they are what make each of these factors 0. So if you want to, you could go ahead and set each of them to 0 to find your critical values. So this is going to be x equals -1 and x equals -2. Those are my critical values. So I'm going to list them out. Critical values, x equals -2 and x equals -1. Why are those values important? Well, they split up my interval for this problem. Okay, so it's when it's equal to 0 or undefined. In this problem, we don't have any cases of being undefined. Undefined would be if we had a fraction. Oops, sorry, you can't see that. So our critical values was when it was equal to 0, which we did here, or when it's undefined, but we don't have a fraction, so we'll have to take a look at that later. Next step, we're going to use test points to determine the solution. And we need to remember to test the critical values. Okay? So here we go. I like to use a chart when I create my test points, so I'll go ahead and draw in how my chart looks. So I'm going to plot my critical values, -2 and -1. Notice they have split my graph into 3 intervals. So we're going to test those intervals. And what am I testing for? I'll get to that in a second. But I'm going to go ahead and draw my box. Notice I split it down right where my interval is. So there are 3 columns because there are 3 intervals that we're testing. And we're going to pick test points from those intervals. And what we're going to test, let's see, in this interval here, what's a number smaller than -2? -10. Why not? What I want to see is if I plug -10 into this equation, will it be greater than 0? That's what I want to know. Will it be greater than 0? Well, to keep things neat, I'm going to fill out this chart. So I'm going to write down my factors. I have one factor, x plus 2, and then my other factor, x plus 1. And those are the only factors I have, so we're going to go ahead and fill that out. Those are the testing columns or rows. Then what I want to see is what the sign will end up to be. So I'm going to write sign. And lastly, the last step is we want this to be, what did we want? We want it to be greater than 0. So I'm going to say, is this greater than 0? Okay, so those are what we do. We set it up with a test point. We pick our factors from our problem. We want to know what the end sign is going to be, and if that end sign fits my problem. Okay, so let's go ahead and check this. If I have -10 and I plug this into here, I get -10 plus 2 and that's going to be a negative. Negative 10 plus 1 will also be a negative. Now notice they are being multiplied together, so this would be negative times negative. What's a negative times a negative? That's a positive. So my sign is positive. Is this greater than 0? Yeah, it is. My answer is yes. So this interval here works for my solution. Okay. Now, question, do I fill in the bubble on 2? No, because we don't have or equal to. It's just greater than. Okay, so let's see. I'm going to pick some test points. A test point in between negative 2 and negative 1. Let's go with 0. If you can use 0, use 0. It's a pretty nice number to work with. And then a number. Ooh, wait, I can't do 0. That's a negative 1. Shucks. Ooh, I can use 0 here, though, because 0 is bigger than negative 1. What's a number between negative 1 and negative 2? Negative 1.5. Let's change the color here. Okay, so go ahead and try to see if you can fill out these columns and what your answers would be. So pause the video, go ahead and fill those out. All right, so you've hopefully attempted these. Let's see. If I plug in this negative 1.5 into this factor, I'm going to get a positive. If I plug it in here, though, I'm going to get a negative, because I have negative 1.5 plus 1. Let me write that down. That'd be a negative. So when I multiply them together, positive times a negative is going to be a negative. Is that greater than 0? No. Nope. Or you can write no. Okay, so I do not fill in this interval. This interval is not part of my solution because it failed my test. And let's test 0. Plugging in 0, that's going to be a positive there. Plugging in 0 here, 0 plus 1 is also going to be positive. Positive times positive is positive. So, is a positive greater than 0? Yep. So, this part is part of my solution. And do I fill in the bubble for negative 1? Nope, because we're not allowed to have it equal to 0. Okay, so there we go. That is our graph for our solution. So all we have to do is write this in interval notation. Once again, it's easier to write your interval notation once you've graphed. So looking at my graph, we start at negative infinity. And we go until negative 2. But we don't include negative 2. And we start up again at negative 1. So let's union these two. And then we go until positive infinity. And there we go. Okay, so I really like this chart. It helps to keep things nice, clean, and concise, and keep your work organized, because a lot of signs are going to be flying around with these kinds of problems. Okay, let's go ahead and try part B. Oh, well, this is nice. It's already set to 0, so we don't have to do the first step. The second step is to identify the critical values. Okay, so let's write this out. Critical values. Well, setting each of the factors to 0 to find my critical values. That's going to end up being x equals negative 3, x equals 2, and x equals 0. So those are my critical values. And if you want to leave them on the side like this, as long as it's labeled, that's good. Okay, let's go ahead and draw our chart. So what values do I have? I have negative 3, 0, and 2. Ooh, this time my graph has been split into 1, 2, 3, 4 sections. So let's go ahead, draw in the chart. Now, let's see. So my test point is always first. My chart is split into 4. And how many factors do I have? I have 1, 2, 3. See the squared factor? That's okay. We can just leave it as x plus 3 squared. We don't have to write this out as 2. So we have x, x minus 2, and x plus 3 squared. Okay, I'm going to go ahead, fill in those columns. And then we want to check the sign. That's always what we're looking for, is the sign, to see if it satisfies my inequality. And lastly, our answer to if it actually satisfies the inequality. What am I looking for? Well, I'm looking to see if my inequality is less than or equal to 0 this time. It's changed. I want to see if this is less than or equal to 0. Okay, so first things first, let's pick the test points. I tend to like to stick with 10s, 5s, and 0s if can. Sadly, 0 is already part of this, so I can't pick that critical values. So let's see. In this section, we can pick negative 10. This section, negative 2. Why not? This section, let's pick 1. Anything bigger than 2? How about 10? Okay, go ahead. Work with those critical values. See what signs you get and what interval you would have that works for our inequality. All right, so let's see. Plugging this in. So negative 10, well, x is going to be negative 10, so that's going to be negative. Negative 10 minus 2 will also be negative. Well, any value squared is always going to be positive, so this is going to be positive. In fact, if you wanted to be sneaky, you could go ahead and put a positive sign the whole way across because it's squared. Okay, let's go ahead and multiply. Negative times negative is positive. Positive times negative, positive times positive will also be positive. Is this less than or equal to 0? No. Check the next one. A negative 2, that'll be negative. Negative 2 minus 2, negative. Negative 2 plus 3 squared, positive. Ooh, same thing. Negative times negative, positive. Positive. Nope. Let's check this point. So 1 is going to be positive. Negative 1 plus 3 squared is going to be positive. And then, so 10, last one. Oh, sorry. We need to fill out the sign part. So positive times negative is a negative. Negative times a positive is negative. So this, is that less than or equal to 0? Yep. And lastly with the 10. So 10 is going to be positive. 10 minus 2 would be positive. 10 plus 3, quantity squared, will also be positive. So positive times positive times positive is positive. Is this less than or equal to 0? No. All right, let's go ahead and fill in our graph. First thing